Hey, this is the video lesson for Chapter 1, Lesson 4 on ratio tables. Use this video as a review, or if you were absent, you should watch this video so you know what you missed. We're going to start with the real-world link, and we'll do one, maybe two. So let's read it. It says, a punch recipe uses 1 container of soda and 3 containers of juice to make 1 batch of punch. Problem 1 says, draw red counters to show the number of containers of soda, and draw yellow counters to show the number of containers of juice needed to make 2 batches of punch. Now, since you're just using a pencil, we're not going to use red or yellow, but this is what we'll do. I'm going to start with zooming in, and I'm going to use counters for the original recipe. Remember, it says 1 container of soda and 3 containers of juice. So what I'm going to do is draw circle with an S in it for soda. That's 1 container of soda and 3 for juice. So I'll put J. Let me make that one prettier. J and J. So that's the recipe. Now remember, it said to use counters to show how much juice is needed to make 2 batches. So if that's 1 batch, I'm just going to kind of double it, add another soda and 3 more juices. And over here, I'm going to write my ratio. So for 2 batches, there are 2 containers of soda and 6 containers of juice. Now, when we go to problem 2, that's the one I'm going to have you do on your own. So in problem 2 says, draw red counters to show the number of containers of soda and draw yellow to show the number of containers of juice needed to make 3 batches. Don't worry about the colors. The main thing I want you to worry about is you're drawing the recipe for 3 batches. So you're going to do that in here, just like we did up here. And then I want you to write the ratio of soda containers to juice containers. So why don't you pause the video and do this one on your own, and when you're done, restart it. Go. Okay, let's see how you did. So for soda, remember, I needed 1 for 1 batch, 2 for 2 batches, and 3 for 3 batches. And for juice, for 1 batch, I needed 3. For 2, I needed 3 more. And for 3, I'll need 3 more. And you can see why I'm not an art teacher. Now, for 3 batches of punch, here should be your ratio. You have 3 containers of soda and 9 containers of juice. By the way, these we call equivalent ratios. They're equivalent because they're equal. They show the same amount comparing soda to juice. All right, now, what does that have to do with ratio tables? Well, let's turn the page. So on this, we're going to talk about equivalent ratios, and we are going to use ratio tables to help us find them. Now, let's read what it says at the top here so you have an idea what we're doing. It says, the quantities in the opening activity can be organized into a table. This table is called a ratio table because the columns are filled with pairs of numbers that have the same ratio. And equivalent ratios express the same relationship between quantities. So let me show you what it means. Remember, we started with the recipe. 1 soda to 3 juices, right? For 2 batches, we had 2 sodas and 6 juices. And then for 3, we had 3 sodas for 9. These are all equivalent ratios. 1 to 3, 2 to 6, 3 to 9. And the point of a ratio table is it kind of is just a nice way to show them. If you didn't use a ratio table, you can write them like this. 1 soda to 3 juice. But the nice part about the table is you only have to write soda and juice once, and then you just put your numbers in. A little bit easier. So let's go down and show you how ratio tables are going to help you out. So in example 1, I went ahead and I erased what the book has in the table. And I know you can look in your book and check it, but I want you to see where those numbers came from. So let's read the problem for us. It says, to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? So let's go through this and break it down a little bit at a time. We'll circle what we know. So we're going to start up here. It says to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. So we're going to go down to our table. Drops of yellow, 6 drops with 1 cup of icing. Okay. Now the question says, and this is what I like to squiggly underline, how much yellow food coloring should you mix with 5 cups of white icing to get the same shade? Now here is the thing. You have to get this 5 in the right spot. So I'm going to circle 5 cups of white icing. And I want to make sure I put it in the box where the white icing is. So the question says how many drops of yellow? Well, this is going to be our answer. So this box I'm shading in green is going to be where our answer is. Now to solve this, here's what I would notice. I know 1, I need the pen, not the highlighter. 1 times 5 is 5, right? So you do the same to the 6. 6 times 5 will get your answer of 30. Now when you write your answer, make sure you label it 30. Even if you just write drops, I'll be okay because I'll know you're talking about the food coloring and not the cups of icing. All right, so that's how that works. Now let's go down to the one below. And this is one where you don't have to do it all in one chunk, but you can. So I'll show you both ways. All right. Now in example 2, it says, in a recent year, Joey Chestnut, and this is a real guy, and this is kind of freaky when you read it. Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. Think of 66 hot dogs. That's disgusting. If he ate at a constant rate, determine how many hot dogs he ate every 2 minutes. Now notice this has that middle column here. That gives us an extra column to do some work. Now honestly, if I were doing it, I would not use the extra column for this one. So if I were doing it, I would just put, it says how many, all right, so 66 hot dogs in 12 minutes, right? So I have that down here. And we need to figure out how many he ate in 2 minutes. So I need to put that 2, make sure it's next to minutes. So I'm going to put it here. Now the reason I'm not using the middle column is because I know to get from 12 to 2, I just have to divide by 6. I can do this in one step. And then from 66 over there, I'm going to divide 66 by 6 as well. And 66 divided by 6 is 11. So that means Joey Chestnut in 2 minutes can eat 11 hot dogs. All right, that's your answer. Now, just to show you how the book was showing you here, I'm going to erase everything here, and you're going to see what the book had. There you go. So look at what the book did. And I think this was kind of weird, but you can do it. So instead of going from 12 to 2, they're like, okay, I know half of 12 is 6. Half of 66 is 33. So they divided 66 and 12 by 2 and got a halfway point. And then they're like, okay, to go from 6 to 2, I divide by 3. 33 divided by 3 is 11. You still get the same thing, but they did it in 2 steps. So if you ever see that middle column, that means it's an extra place to show some work. Now let's go down below. And we're going to try or do one together. And then I'm going to, actually, you know what I'm going to do? I want you to just try problem A, not B yet. So do problem A and do it on your own and fill in your table, answer your question, but then restart the video when you're done to see if you were right. Okay? Go ahead. All right, if you're restarting the video, you should already have problem A done. So let me read it to make sure you did the right thing. Problem A says, a patient receives 1 liter of IV fluids every 8 hours. At that rate, find how many liters it will take to receive 4 liters of IV fluids. Now, they are nice enough to write some numbers in here for you, but they're not always going to do that. So 1 liter of IV fluids, see how it's labeled? In 8 hours. Time, that H means hours. And this says for 4 liters, how much time? Well, this is what you should have done. You should have said, I know 1 times 4 is 4. So then you do 8 times 4, and you get 32. So that means it's 32 hours, and over here on the line, you should write 32 hours. If you didn't label it hours, make sure you do that. Now, in problem B, I want you to do the same thing. If you made any mistakes in A, you learn from it, and now you're going to try B by yourself. So do B, pause the video, and when you're done, watch it and make any corrections. Go. All right, let's see how you did. So let me get my trusty highlighter on here. And it says, to make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. It's a lot of sugar. Can't be too healthy. Find the amount of sugar needed for 4 cups of cranberries. So let's check it out. 12 cups of sugar for every 16 cups of cranberries. Sugar, 12. Cranberries, 16. Okay? And this says find the amount of sugar needed for 4 cups of cranberries. So they put the 4 over here. Okay? This is one where I don't think you probably need that, but you could have used it if you didn't want to go all the way. But check this out. To go from 16 to 4, you just do 16 divided by 4. To get your answer, you do 12 divided by 4, which is 3. So your answer should be 3 cups of sugar. All right. Hopefully you did well on those. If not, as you do each one and make corrections, you learn from it and you get better at it. But now, as we go to these next ones, it's going to get a little trickier. Now, this says use scaling. I'll tell you what scaling is, and I'll tell you kind of what it means in my own words. Multiplying or dividing two related quantities by the same number is called scaling. You may need to scale back and then scale forward to find an equivalent ratio. You probably have no idea what that means when they said it because, you know, math definitions are always kind of dumb like that. So I'm going to write this down here. What scaling really means is reduce first. And this is just a strategy. I call it the reduce first strategy that you use in certain situations. So let me show you why. Now, again, notice this middle column. For extra work, we are actually going to need it this time. So, this says cans of corn are on sale at $10 for 4 cans. So notice they have $10, or I'm sorry, I read that wrong. Cans of corn are on sale at 10 for $4. That's 10 cans of corn for $4. So 10 cans, $4, right? Find the cost of 15 cans. So they wrote 15 cans. Notice it's cans. You always have to write it in the right spot. So here's where you run into a little bit of problem. You're like, okay, 10 times what is 15? Now, you can actually figure out 10 times something is 15. There is a decimal number that you can multiply 10 by to get 15. And if you know it, you're welcome to use it. But this is how scaling, or the reduced first method, works. So what I'm going to do is I am going to reduce this fraction here, because I see 10 and 4 are even. So if I cut both of those numbers in half, so 10 divided by 2, that's how you cut a number in half, is 5, right? And 4 divided by 2 is 2. Now, I am going to use these smaller numbers to get my answer. No longer going to use the 10 to 4, so I don't even need to look at it. So check it out. 5 times 3 is 15, right? 2 times 3 is 6. So that means it's going to be $6. So what I did, just to show you again, is when I noticed, let me erase all this mess, when I noticed that 10 did not go into 15, I reduced this here. I reduced this down to 5 to 2, because 5 goes into 15. Right? That's when you reduce first. So let's go down and let's try it in example 4. Now, I'm going to go, let me pause real quick, and I'm going to go over example 4, and notice I erased everything in this box even though it's in your book, because I don't want you looking at that now. I want you to see how you get those numbers. So I'm going to start by reading the problem and putting the numbers in my ratio table. This says Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. So let's go down and write those numbers in. 14 hours, 8 lawns. So number of hours, I didn't want to do that. I forgot to make my pen then. 14 hours, 8 lawns. At this rate, how many lawns could he mow in 49 hours? So I'm going to put that 49, make sure it's hours, so the 49 should go here. Okay, so 14 into 49, well, guess what? It doesn't go. Well, unless you figure out the decimal. And if you know how to do that, I'm okay if you do that. So here's what I'm going to do. I'm going to reduce first. So I'm going to cut, I see both of my numbers are even. See how 14 and 8 are both even numbers? That means I can divide them by 2. So let me start by dividing by 2. So 14 divided by 2, this is reducing first, guys. 8 divided by 2, and I get 7 and 4. Now, the reason I did this is because now 7 goes into 49. So remember, I'm now looking at my new numbers. 7 times 7 is 49. So you do 4 times 7 is 28. So that means in 49 hours, you could do 28 lawns, which I guess that should be here. Should write it on the line. All right, the reduce first method is going to come in handy, and it's going to come in handy right below. So we'll get you set up, and then we're going to have you pause and try it. So this says, a child's height measures 105 centimeters. Estimate her height in inches. So here's what we know. And I'll tell you where these numbers came from. They're giving this to us because if you have 25 centimeters, that's about the same in 10 inches. All right, so that's where these two numbers came from. It's just a conversion. 25 centimeters is about 10 inches. So remember, the child's 105 centimeters, so the 105 has to be next to centimeters. Now, here's what you're going to notice. 25 does not go into 105. So what I want you to do is you're going to pause this video. Remember, you're going to have to reduce this first and get nicer numbers, and then see if you can get this. So try this one on your own. If you really get stuck, now you have to try it first before you can say you're stuck, then watch the video and do it with me. But I really want you to try it first because that's how you're going to learn and get good at it. All right, go ahead, pause the video, restart it when you're ready. Okay, let's see how you did. Now to reduce 25 and 10, you can't divide by 2 because 25 divided by 2, it's an odd number, it doesn't divide by 2. But I know 25 and 10 can divide by 5. And I know that because every number that ends in a 5 and ends in a 0 divides by 5. So that's how I'm going to reduce first. I'm hoping you did that too. So 25 divided by 5 and 10 divided by 5. Okay, 25 divided by 5 is 5. 10 divided by 5 is 2. Did you make it this far? Okay. Now you need to figure out how do you go from 5 to 105. Now, if you're stuck, if this means, remember, 5 times what is 105? You can always do 105 divided by 5 to figure that out. So if you do 105 divided by 5, I know I get 21. So that means 5 times 21 is 105. 2 times 21 is 42. That means her height in inches will be about 42 inches when she's 105 centimeters tall. All right, on to the last page. One more example, maybe? Yes, and then you're going to do some problems on your own. All right, so I went ahead and I deleted everything in here so you can watch how those numbers came about. And I know they're in their book, just don't look at them. So this is a real world example. When might you use ratio tables to help you out? And I see we're talking about Canadian dollars versus American dollars. So on her vacation, Leia exchanged 50 American dollars and received $60 Canadian. So I'm going to write that in the box here. So 50 American, right? Oops, wrong color. 50 American dollars. So make sure that goes where the American is. And she received 60 Canadian dollars. Okay, notice that's where Canadian is. Use a ratio table to find how many Canadian dollars she would receive for $20 American. So I'm going to put that $20 American, make sure it goes where American is. Okay, so now set up a ratio table, use scaling to find the desired quantity. All right, let's check this out. The reason is I can't go from 50 directly to 20. I can, but it's a decimal number, so maybe I can't figure that out. So I am going to reduce first. Now take a look at 60 and 50. I notice they both end in a 0. Every single number that ends in a 0 can be divided by 10. So I'm going to divide each number by 10. So 60 divided by 10 is 6, and 50 divided by 10 is 5. So that's how I reduced it. Now I'm going to use my smaller numbers. Are you ready? So 5 times 4 is 20. 6 times 4 is 24. So Leah would receive $24 Canadian for $20 American. All right. That's the examples. If you're stuck, you can always go back and watch one of the examples. Now, if you are absent, you're going to be working on the problems below. You're going to be doing number 1, 2, and 3. Remember, if you can't figure out how to go from one number to the next, you're going to have to try the reduce first strategy. Also, I want to point out something. You see here? Example 1 is written after number 1. Example 2, example 5. If you have trouble with number 1, go watch the video back when I went over example 1. Remember 2 pages ago. If you have trouble with 2, go back and watch the video for example 2, because example 2 is just like this one. And example 5 is just like number 3. Do those on your own, and you're done with me in the video. Thanks for watching. I hope I helped you. Later.